Hello, ladies and gentlemen. We are going to be starting a new unit on similarity. So today we will be starting with a little bit of review from algebra on ratios and proportions. So before we get started, make sure you have the Unit 5 chapter divider and have that glued into your notes, and also make sure that you have the foldable for this video as well. Our learning target for today is that I can reduce ratios and use them to solve problems and in geometry problems as well as real life problems. So before you glue in your foldable, I want you to write down after your chapter divider some information. So this first section is called ratios and proportions and similarity. So if you want to title that, you can. And our first definition is a ratio. The definition of a ratio is a comparison of two quantities. They can be written as a fraction, such as a over b or a divided by b, or a to b with a colon. And they are always in simplest form, or they're always reduced. Our next definition is a proportion, which is an equation stating that two ratios are equal. To solve, you can cross multiply, or you can multiply the means by the extremes. If we have a divided by b is equal to c divided by d, the means are a and c, and the b and d are the extremes. For this example, 2 over b plus 3 is equal to 4 over b. I always cross multiply, but it's up to you how you were taught. So I would take 2 times b and set it equal to 4 times the quantity b plus 3 and then solve for b. So now that we've gone over our definitions of proportion and ratios, we're going to need that blue foldable. It should look like this. We're going to go through 6 problems, and so the problem is written on the outside, and you can just open the flap and write the problem on the inside. So let's open that first flap for our first example. The ratio of b to c to d to c is 2 to 9. So we want to find the value of x and then to find the area. So we were given a ratio and we can come up with another ratio to make a proportion. That's how we're going to do this example. So we were told that one of our ratios is 2 to 9. So we can write that as a fraction, 2 divided by 9. And they also gave us BC to DC, line segment BC to line segment DC. Well, we know that BC is equal to the value of x, and then we also know that DC is 30. So for my second ratio, I'm going to set it up as the same way, in the same way, like the numerator is representing the same thing. So we would put x in the top, and then we put 30 in the bottom because we said BC to DC. So x over 30 is equal to 2 over 9. So I'm just going to cross multiply. 2 times 30 is 60, which is equal to 9 times x, which is 9x. And then we're going to divide both sides by 9. And this isn't going to reduce down simply, so we can take a 3 out of the top and the bottom, leaving us with the fraction 20 over 3. But they didn't want us to just find the value of x, they wanted us to find the area. So what we have to do is, remember, area is equal to length times width. And here it doesn't matter, you can say 30 is the width and x is the length. So we'll say a is equal to 20 divided by 3, all multiplied by 30. When we multiply fractions, we multiply top times top over bottoms times bottom, and 30 is the same thing as 30 over 1. So we can say a is equal to 20 times 30, which is 600 divided by 3, which is 200. And don't forget your labels, so units squared, because we're talking about area. So let's open our second flap for example 2, and if you want, you can choose to redraw the diagram in the inside flap, if you so choose. That's up to you. If you want to, you can pause the video and then we'll join back later. So we are given that the ratio of AB to BC is 3 to 2, and the perimeter of the rectangle is 60 inches. Find the length and the width. Well, back in algebra, we should have remembered that perimeter is equal to length times length, length plus width, which is the same thing as 2 times length plus 2 times width. So just keep that in our back pockets. Okay, and then for the ratio, we said AB is 3 to 2. So we don't know that the side length of AB is 3 units. We just know it's 3 to 2. So it could be 3 and 2, it could be 6 and 4, it could be 9 and 6, it could be a lot of different things. So that second number that we're multiplying by, we can just let it be represented by a variable. So we can say 3x and 2x. So this can, and it's up to you. If you want to let AB be the length or the width, that's totally up to you. I'm going to say length is 3x and W is 2x. So now that we have an equation that we can plug L and W into, that's exactly what we're going to do. So we said perimeter was 60, right? So 60 is equal to 2 times the length, and in this case it'd be 3x plus 2 times the width, and that would be 2x. So 2 times 3x is 6x plus 4x, all equal to 60. 6 plus 4 is 10x, still equal to 60. Divide both sides by 10, divide both sides by 10. 6 is equal to x. But they wanted us to find the length and the width. So x is equal to 6, but that's not my answer. I want to find L and W. So here I'm going to write length is equal to 3 times 6, which is 18, and width is equal to 2 times 6, which is 12. And we are in inches. That is our unit. So that is my answer. Okay, so let's open up our third flap for example 3. The ratio of length to width is 4 to 3 and the area is 48 square units. What are the length and width of the diagram? So I'm just going to say that this side is going to represent length and this side is going to represent width. And here we're talking about area, so I'm going to want to know the formula for area of a rectangle, which is just length times width. So they also told us that the ratio of length to width is 4 to 3. But we don't know if the length is exactly 4. It could be 4 times another number. Either way, the relationship between the length and the width, those two sides, is 4 to 3. So in order to know what the true length is, we have to find x. So we're going to say length is equal to 4x and width is equal to 3x. So we said that we can just plug 4x and 3x into our formula. So area, which in this case we said was 48. So 48 is equal to length times width. And in this case, length is 4x times 3x because 3x is our width. So 4 times 3 is 12x squared because remember x times x gives me an x squared. And that's still equal to 48. Then we can divide both sides by 12, both sides by 12. We are left with 4 is equal to x squared. In order for my last step to solve for x, I have to undo this squared, which is going to be done by a square root. So we found x to be 2. The square root of 4 could be 2 or negative 2, but since we're talking about distance, it's always going to be positive in this case. Again, they didn't ask me for my x, they asked me for length and width. So we said length was 4x, so 4 times 2 is 8 units. And then width was 3 times x, which is 3 times 2, so 6 units long. Okay, so let's open up to number 4. The angles in a triangle are in the extended ratio of 4 to 3 to 11. What are the angles? So first on my triangle, I'm just going to label my angles. I'm going to say 1, 2, and 3. So we are trying to find the measure of these 3 angles. We're trying to find the measure of angle 1, which is going to be some degree, the measure of angle 2, and the measure of angle 3. That is what we're looking for. And they also gave me a ratio of those 3 things. Well, remember from last unit, the triangle sum theorem says that angle 1 plus angle 2 plus angle 3 is equal to 180 degrees. And whenever we have a ratio and no other variables or no second ratio, just like the last 2 problems, we're going to assign an x to each. We're just saying the relationship between the 3 angles is 4 to 3 to 11. But it could be doubled that or tripled that. But either way, the relationship's the same. So we have to have a variable represent our possible difference in the number because it might not be 4, because it can't be 4 degrees, 3 degrees, and 11 degrees, right? Because that added together does not equal 180. So we're going to have to multiply each one of these things by some constant, which we're going to call x for now, so that we can figure out what the true measure is of each angle. So that's all equal to 180. So 4 plus 3 plus 11 gives me 18x equal to 180. So if we divide both sides by 18, x is then 10. But that wasn't my answer. We wanted to find the measure of angle 1, 2, and 3. So let's say the measure of angle 1 is this 3x, and angle 2 is 4x, and angle 3 is 11x. 3 times 10 would be 30 degrees. 4 times 10 would be 40 degrees. And last but not least, 11 times 10 would be 110 degrees. And those three numbers added together do add up to 180. So we know that our measures are correct. And would it have mattered if I said angle 2 was 40 degrees and angle 1 was 30, or if angle 1 was 40 degrees and angle 2 was 30 degrees? It wouldn't. I just needed these three separate numbers, 30, 40, and 110. Okay, so example 5, the perimeter of a rectangle's front lawn is 192 feet. The ratio of length to width is 5 to 3. Find the area of the lawn. So here we were only given one ratio. So in order to set up an equation to figure out the area of the lawn, we have to find the constant that's being multiplied by 5 and 3 to maintain this relationship. So we're going to need that equation for perimeter again, which is 2 times the length plus 2 times the width, or L plus L plus W plus W. So in that case, we said the length to width is 5x to 3x. So, or 5 to 3. So we're going to say the perimeter, which is 192 feet, is equal to 2 times 5x, because we don't know for sure if the one side length of the rectangle is 5 units. It could be more than that. And then we also know the width is going to be 3x. So 192 is equal to 10x plus 6x. So 192 is equal to 16x. Divide both sides by 16. X will be equal to 12. Okay, so they want us to find the area of the lawn. And remember, area is length times width. So for this, we need area equal to 5x times 3x. And we know that x is 12. So the area is going to be 5 times 12 times 3 times 12. Well, 5 times 12 I know is 60. And I know that 3 times 12 is 36. So now 60 times 36, and if you need your calculator for this, that's totally fine, but it should be 2,160 feet squared, because we were talking about feet in this example. Last but not least, example 6. I saw on your foldable that the image is very, very, very hard to read. So if you want to write this 60 on that one side length from A to B and 10x plus 15 from the side length B to C, go ahead and do that. You can pause your video if you need to. So we have the segment AB to BC, that ratio is 3 to 4. And they gave me numbers or algebraic expressions for both side lengths. So I can set up two ratios and then put them equal together to get a proportion, cross multiply, and solve. So this one should be pretty easy. AB we said was 60 compared to 10x plus 15. So 60 over 10x plus 15 is equal to 3 over 4. So this is our proportion. And now we're going to cross multiply. So we're taking 60 times 4, which is 240. And then we're taking 3 times 10x plus 15, that whole quantity. So now we're going to have to distribute. So 3 times 10x is equal to 30x, and 3 times 15 is equal to a positive 45. And bring down our 240 because we haven't done anything with that yet. Now we just have to solve for x. So subtract 45, subtract 45. We should get 195 is equal to 30x. And now all we have to do is divide by 30, divide by 30. This isn't going to come out to be a clean number. It should be 6 1.5 units. So if you needed your calculator for that, that would be just fine. I just want to thank you guys all for taking such good notes, and you should be able to work on your practice ratios and proportion worksheet. And I will see you tomorrow.